Hopes all are doing well. I have already sent you the soft copy of the multiple choice questions, that is CET JE questions on relation and functions last week. So today let us discuss those questions. Defined by is given R is equal to ordered by x comma y such that x plus 3y is equal to 12, x belongs to n, y belongs to n. The question is to find R. Look at the question. Let R be the relation on set of natural numbers. Relation is defined from set of natural numbers such that ordered by x comma y, where x plus 3y is equal to 12, x belongs to n, x belongs to natural number, and y belongs to natural number. We have to check what is that relation R, and 4 different options are given. Okay. So let us solve this equation and see which option is correct. Before I check, look at the options once. 8, 1, 6, 2, 3, 3. What is that? Ordered by 8, 1. 8, 1, 6, 2, 3, 3. All the first element, corresponding first element are called as domain, and the corresponding second element is called as range. Right? You know that. So that is, domain is denoted by x and range is denoted by f of x, or also known as y. Okay, so in all the options, if you see, you can find 1, 2, 3, 1, 2, 3 in the place of range. Okay, so let us rewrite the equation in such a way that we can substitute the value of y as 1, 2, 3. Okay, so let us see how to rewrite this equation. Can I write this as x is equal, actually the equation is x plus 3y is equal to 12, right? So I will rewrite this equation as 3y is equal, or else I can write it as x equal to 12 minus 3y. I can either write 3y is equal to 12 minus 6, that is the one now. So I will write like this. The reason is, if I put y is equal to 1, because in the options you can see the ranges, that is the value of y is 1, 2, 3, 1, 2, 3, all the 4 options, they have the same. So I will put y is equal to 1. Okay, if I put y is equal to 1, x will be 12 minus 3 into 1, right? 12 minus 3 is 9. Okay, if I put y is equal to 2, x will be equal to, if I put y is equal to 2, 12 minus 3 into 3 into 2 is 6, 12 minus 6 is 6, so x will be 6. Next, if I put x equal to 3, okay, if I put x, not x, y. If I put y is equal to 3, then x will be equal to 12 minus 3 into 3, 12 minus 9, and that will be 3. So if I want to write this as order where, I can write this as 9, 1, x, y, 6, 2, and 3, 3. So we can make out the option as third option is correct. Okay, the answer is third option. Look at the second problem. If R is equal to ordered by x comma y, R is equal to ordered by x comma y such that x comma y belongs to integer. X comma y belongs to integer, and x square plus y square equal to 25. X square plus y square is equal to 25. Okay. Then the domain of R, the question is we have to find the domain. Know the definition of the domain. If the ordered pair x comma y is represented in such a way that x represents the domain, all the first element of the ordered pair represents the domain, and all the second element represents the range. Okay. So here the question is to find the domain. quoted all values x and y take, x and y take, so that we get 25. Look at the given equation. This is the given equation. And substitute only the integers such that x square plus y square will give to 25. Okay. So if I put x as 0 and y as 5, what happens? See, integers means it can be minus 3, minus 2, minus 1, 0, 1, 2, 3, right? You know the integers, set of integers, you know. So I can put 0 also. In case I put x 0 and y as plus 5, what happens? 0 square plus 5 square, it will be 25. What if I put y as minus 5? Can I put minus 5? Minus 5 square is also 25. So the first set of ordered pair can be 0 plus or minus 5. Okay, what I am writing is the relation. Okay, first I will define the relation. If x is 0, y can be plus or minus 5. So that I get x square plus y square as 25. 0 square plus 5 square is 25. 0 square minus 5 the whole square is also 25. So I got one element, that is 0, plus or minus 5. I can even change x and y. What if x is plus or minus 5 and y is 0? Once again it gives me 25. 5 square plus 0 square is 25. Or minus 5 square plus 0 square is 25. So I got two elements. Any other elements can I find so that just by squaring I get 25. What values can I substitute in the place of x and y? See, 3 square plus 4 square. 3 square is 9, 4 square is 16. 16 plus 9 will be 25. So I can write two more elements. Which are those? One is plus or minus 3, plus or minus 4. I'll write it together, okay? Because even minus is possible. Minus 3 the whole square is same as 9 only. And minus 4 the whole square. So plus or minus 3 square plus or minus 4 square will give you 25. Or I can even write plus or minus 4 plus or minus 3. If I interchange, it's given x and y belongs to integers. If this is 4 square and this is 3 square, again it gives me 25. So this will be the relation. No other element. It should be only integers. You cannot substitute any other value. Okay. So it can be, the relation can be 0 plus or minus 5, plus or minus 5, 0, plus or minus 3, plus or minus 4, plus or minus 4, plus or minus 3. Okay. Now this is the relation. But according to the given question, the question is to find the domain of R. We need to find the domain. You know what is the domain? Domain is the set of all first element of the ordered pair. So which are the first element of the ordered pair? You know, domain is set of all first element of the ordered pair and range is set of all second element of the ordered pair. Okay. So here I can write 0 plus or minus 5 or plus or minus 3 or plus or minus 4. Okay. So this would be the domain. So if you want to see the options, I can write this as 0. If I want to write in the form of integers, I can write minus 5, minus 4, minus 3, 0, 3, 4, 5. Okay. So option 1 is correct. Option 1 will be the answer. Look at the third one. If A is equal to x such that x belongs to whole number and x is less than 2. Okay. Set A is given. And set B is x such that x belongs to natural number and x lies between 1 and 5. Okay. And set C is 3, 5. Set ABC is given. set A and B is given in set builder form and set C is given in roster form. Now the question is, we have to find the number of elements in N cross B union C. Okay, to find that B union C, A cross B union C, I need to find how many elements are there in set A and set B. So first let us see what are the elements of set A. So set A is, see how it is defined. X is such that X belongs to whole number. Now whole number starts from 0, 1, 2, 3 and so on. And X is less than 2. Whole number less than 2. So the elements can be 0 and 1 because it is given less than 2. So only 0 and 1 are the elements of set A. Okay. And set B is, X is such that X belongs to natural number and X is greater than 1, less than 5. Natural number starts from 1 and it's given greater than 1, less than 5. So I cannot consider 1, I cannot consider 5. The natural number between 1 and 5 is 2, 3 and 4. Okay, so we have the set A, set B and set C. What should I find as number of elements in A cross B union C? I have to find this number of elements. Before I find number of elements, I'll find what is the set A cross B union C. Before I find A cross B union C, first I'll solve B union C. Okay, B union C as, this is set B and this is set C. The union will be 2, 3, 4 and 5. This is B union C. Next it is find A cross B union C. This is set A cross B union C. You know all those things, how to find. So A cross B union C will, you know how to write A cross B, Cartesian product. 0, 2, 0, 3, 0, 4, 0, 5. Next is 1, 2, 1, 3, 1, 4, 1, 5. Okay. A cross B union C. A cross B union C. 0, 2, 0, 3, 0, 4, 0, 5. 1, 2, 1, 3, 1, 4, 1, 5. But what I want is number of elements. Number of elements in A cross B union C. So not how many numbers are there, how many elements are there. 1, 2, 3, 4, 5, 6, 7, 8. So there are 8 elements in A cross B union C. So the answer will be 8. And that is option 4. Third one, fourth option. Answer is 8. Look at the fourth one. The relation R is such that a relation R is given in set builder form. Okay, I have to check how it is in the set builder form. The options are given in set builder form. The question is given in roster form. I have to check which is the correct form, that is in set builder form out of those 4 options. Now look at the first option what is given. R is equal to ordered by x comma y such that x minus y is equal to 2 and x is greater than 4, less than 8, x comma y belongs to natural number. Can I tell this option is correct? Look here, x minus y is 2. No, this is x, this is y. First element is x, second element is y. minus 2. According to this relation, x minus y is plus 2. One example is enough to prove it's wrong. 5 minus 3, yes, that is satisfying, 2. 6 minus 4, even that is 2. Okay. But 4 minus 6 will give you minus 2. 7 minus 5 will give you 2. But 5 minus 7 will give you minus 2. So 3, 5, 4, 6, 5, 7 is not satisfying this option because x minus y is plus 2. Sometimes I am getting plus 2, sometimes I am getting minus 2. So first option is not correct. This will not satisfy the given relation. Okay, so first option is wrong. In second option, it is given r such that r is equal to ordered by x comma y such that it's given y minus x is equal to y minus x is equal to rest all it is same. Okay. Can I tell y minus x is equal to 2? Not always one side. Y minus x means second element minus first element. 5 minus 3, 2. Okay, it's satisfying. But 3 minus 5, it's minus 2. 4 minus 6, minus 2. So once again, not always. All the elements are not satisfying this relation. Not the first option, not the second one also. Here y minus x is not always 2. Sometimes it is minus 2. So even second option is not correct. Now go to third option. It's given ordered by x comma y such that mod of x minus y is equal to 2. X is greater than 4, less than 8 and x comma y belongs to natural number. Whether this option is satisfying, mod of x minus 2. Mod means if I get negative value inside the modulus also, that can be written as positive. 3 minus 5. Mod of 3 minus 5 is plus 2. Mod of 5 minus 3 is also 2. Mod of 6 minus 4 is also 2. 4 minus 6 is also 2. Mod. Whenever mod comes, minus 2 will become plus 2. So all the elements are satisfying this relation. This relation that is satisfying. Let us check the condition now. Whether it's satisfying this condition, let us see. It's given x is greater than 4 and less than 8. X is greater than 4, less than 8. X and y belongs to natural numbers it is given. So what are the elements x can take? X can take the element which is greater than 4. Greater than 4 means it can be 5, it can be 6, it can be 7. Not even 8 because less than 8. Okay. Now look at x term in this relation. Look what are all x terms are. 3. 3 is not here. 5 is there, 6 is there, 4 is not there, 7 is there, 5 is there. But this 3 and 4, okay, the condition for x is greater than 4. But I have the element which has 3 and 4 also. So once again this option is not satisfying. This condition is satisfying, but this is not satisfying. X is greater than 4, less than 8. Because there are some element of x which has 3, 4 and all. According to the given option, x is greater than 4. That means x should start from 5. Okay, once again third option is not satisfying. Now let us go to the fourth option. What is that? Mod of y minus x is 2. Mod of x minus y minus x, one and the same. Because inside the modulus, negative sign is neglected, right? And what is given as here, it's given x is greater than 2 and less than 8. Now let us check whether this option is satisfying. Okay. Mod of y minus x is 2. Mod means minus becomes plus. So 5 minus 3 is 2. 3 minus 5 is minus 2. Under modulus it becomes plus. 4 minus 6, once again it becomes plus 2. 6 minus 4, modulus becomes 2. So all the options are satisfying this relation. This is satisfying. Okay. Even it should satisfy the range also. Even it should satisfy this condition also. X is greater than 2, less than 8. Whether it is true, x is greater than 2 means x can carry value 3 6 is there, 4 is there, 7 is there, 5 is there. So even this condition is satisfying. X is greater than 2, less than 2. So here fourth option is there. Okay, fourth option. Let's go to the fifth one. If n of a is 2, if n of a is 2 and total number of possible relations from set A to set B is 1024, then n of B is asked. Then n of B is asked. Okay. Try to understand the question correctly. Total number of possible relation from set A to set B. So while studying relation, you have studied one note there. If number of element in set A is 3 and number of element in set B is Q, then total number of relations from set A to set B will be 2 to the power P into Q. Isn't it? You have studied this relation, this note under relation, right? If number of element in set A is P, number of element in set B is Q, then total number of relations from set A to set B is 2 power P into Q. Okay. Now, according to the given data, n of A is given, that is 2. N of A, I'll consider it as P and I know it's 2. N of B is asked, Q is asked. We should find Q. And total number of relations from set A to set B is given. Total number of relations from set A to set B is how much? 1024. 1024. See, this is the notation for set of relations from set A to set B. And we know this value, that is 1024. Okay. So using these two data, I will find number of elements in set B. Okay. So I can write, look here, n of A 2. For time being, I will consider it as P. Total number of relations from set A to set B is 2 power P here considered. So I know the value of P. The question is to find Q. Okay. So 2 power PQ is 1024. This is given. Okay. Using this condition only, I can find the value of Q. What is that Q? Number of elements in set B. Okay. So see how can I write this? 2 to the power P. P is what? 2. We know that. 2 whole to the power Q. Can I write like this? See, I have studied one notation. A power n whole power n is same as A power m into n. I can write A power m into n as A power m or A power n power n anyhow. Okay. So using that I have written like this. Okay. That is equal to, I'll divide this and see by 2. That is written here. 1024 divided by 2 if I do 512. This will be 256, 128, and this will be 64, 32, 16, and 8, 4. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So this can be written as 2 power 10. Okay. 1024 can be written as 2 power 10. Look here. Now, can I split that 2 power 10 as 2 to the power 2 whole to the power 5? I have already told you A power m is A power m into n. So 5 into 2 is 10. I can even write A power m to the power n. I can write like that. Okay. And this is 2 square to the power q. When comparing both left hand side and right hand side, can I tell the value of q is that Q? Number of element in set B, and that is 5. Okay, so number of element in set B is 5. This question has appeared in CET 2020 this year. Okay, CET 2020. Next we'll do the sixth one. I hope this is clear how total number of relations are given, number of element in set A is given. So using this condition, how many relations can be formed from set A to set B? Using this condition, I can get the number of element in set B. Solving this. Simple. Next question is domain of f of x. We need to find the domain of f of x, and that is equal to 1 divided by root of x square plus 2x plus 9. The question is to find the domain. Okay. So before I explain, you know what is domain and range, right? See, f of x is equal to y. Okay. Domain is what possible value I can substitute in the place of x such that f of x or y is a real number is called a domain. Okay. I have to substitute the value of x in such a way that f of x is always defined and it should be a real number. Okay. So that is the domain and the range. Now, you know the indeterminate forms, right? So here we come across two indeterminate forms. One is any number divided by 0. Any number divided by 0 is not defined. That is indeterminate form. Also, if we get 0 by 0 form, even that is indeterminate form, not defined. Okay. So, whenever we get any number divided by denominator as 0, so that number is not defined. Also, 0 by 0 is not defined. Also, root of negative value inside the square root, if we get negative value, that is not a real number once again. That comes under complex number, which to be studied at. Okay. So, once again, that is not a real number. So, I have to see that I am not getting any of these forms. Okay, then only f of x is defined, as range is defined. Look here. Now, the question is to find the domain. What do you mean by domain? What value we can substitute in the place of x such that f of x is real. F of x is defined and it is a real number. Okay, so you came to know that 1 divided by 0 if I get, then it is not defined. So I will avoid 0 in the denominator. Okay. If it is not 0, and if I get any other number in the denominator, f of x is real. Okay. So my intention is I have to avoid 0 in the denominator. So what I do is f of x is defined. F of x is defined only if when the denominator is not equal to 0. 1 divided by 0 if I get, then it is not defined. Okay. So, and inside the square root, I should not get negative value. Okay. So, in this case, f of x is defined only if x square plus 2x plus 9 is greater than, can I tell greater than or equal to or only greater than 0? It should be greater than 0. F of x is defined only when this term, that is x square plus 2x plus 9 is positive, not even 0. What happens if this is 0? Root of 0, 0. 1 divided by 0, not defined. Okay. And what if it is negative? What if this is less than 0? Root of negative value, once again, it's not a real number. Is it clear? So this function f of x is defined only if the value x square plus 2x plus is positive. Okay. Now looking at the options, can you make out? See, options are 1 comma open interval 1 comma 0, 1 comma 2, minus infinity to infinity, 0 to infinity. How will you make out which option is correct? What are the values satisfying x? Looking at this, now you cannot make out. Okay. So I'll try to make it as a perfect square. Can I write this as x square plus 2x plus 1? Look here. I'll split that 9 to 1 plus 8. Okay. Because I'll club this term greater than 0. The reason is x square plus 2x plus 1 is x plus 1 the whole square plus 8 greater than 0. Okay, now I can easily make out what values I can put in the place of x. What if I put 0? I get positive numbers greater than 0. What if I put negative numbers like minus 2, minus 3 and all? Minus 3 plus 1 will be if I get negative number also, while I square what happens? It becomes positive. Some positive number plus positive number, again it's a positive number. Whatever number if I substitute in the place of x, it can be minus, negative value, it can be 0, it can be positive value, or it can be 0.75, whatever number, any real number if you substitute in a place of x, adding 1 and squaring it becomes positive. Plus 8 if you do, however it's positive. Okay, so looking at this, you can now guess which option would be correct. Okay, any real number you can substitute in the place of x. Now what is x? X is the domain and the question is same, find the domain. Okay, so the domain here will be domain as set of real numbers, set of all real numbers. Okay, according to the given option, I can tell minus infinity to infinity. This is how we denote set of real numbers. Minus infinity to plus infinity, open bracket. Okay, we don't know what is that minus value. Minus infinity, infinity value, we don't know. So open interval there. This is how we represent set of real numbers. You have studied in that interval, sub-interval symbol. So this would be the answer, set of real numbers. I hope it's clear how do we find that is a set of real numbers. Looking at this equation, you cannot make out, right? Any values you can substitute in the place of x. It can be minus. So you can check, however, if you put some values and you can make out, it will be positive. But if you proceed like this, x square plus 1 whole square means it's understood. Whatever number you will substitute in the place of x, it will be positive. So any real number, if you put 0 also, you will get greater than 0. If you put negative numbers also, greater than 0. Okay. So here the answer is set of real numbers, minus infinity to infinity. Next one, seventh one. We need to find the domain and range of the real function f defined by domain and range. We have to find both domain and range for the given function f of x. See, f of x is 4 minus x divided by x minus 4. Once again, looking at the function, you can tell when the function is not defined. If the denominator is 0, then the function is not defined. Right? Numerator, any value, but in the denominator, if it is 0 divided by any number, also it is 0. But any number divided by 0 is not defined. Right? So, f of x is defined only if f of x is defined if denominator is not equal to 0. What is the denominator? X minus 4 should not be equal to 0. Okay. Now x minus 4 not equal to 0 means if I shift that minus 4 that side, it becomes plus 4, which implies x should not be equal to 4. Okay. So what is the domain here? Domain can be any real number excluding 4. X should not be equal to 4. and it can be any number. So I can tell domain is all real number, it can be any real number excluding 4. Subtract that element 4. What happens if I put 4 here? 4 minus 4, 0, divided by 0. 0 by 0 form, once again, indeterminate form, not defined. Okay. So, excluding that 4, if you put any number, f of x is defined. Defined means f of x will be any of the real number. Real number means it can be 0, negative numbers, some decimals, whatever number, but not undefined number like 0 by 0, 1, any number divided by 0. Excluding that, it can be any of the numbers. Okay. So looking at the domain, you can tell which option is correct. Because in the first option, domain is all real numbers. Second option, r minus 1. Third is r minus 4. And the fourth option is r minus of minus 4. So looking at the domain, you can make out the third option is correct. But still, let us find the range. Okay. Now, what is the range for this? Okay. To solve that, what I will do is, here I am having 4 minus x. Here I am having x minus 4. I take minus common from the numerator. If I take minus common, I can write it as x minus 4. Correct? If I take minus outside, I can write 4 minus x becomes x minus 4 divided by x minus 4. Okay. So can I cancel this x minus 4, x minus 4? Yes. So what is left? Minus 1 is left. So whatever real number you put, excluding 4. Domain is real number excluding 4. Whatever, you can't put 4. You understood right? If you put 4, 0 by 0 form, not defined. Okay. So any real number if you substitute in the place of x, your range will be always minus 1. Always. Any number you try. Put 5 and see. 4 minus 5, minus 1. 5 minus 4, 1. Minus 1 divided by 1 is minus 1. Any number, if you put 0.75 to 1 also, you will get minus 1 only. Any number if you substitute in the place of x, any of the real number, excluding 4, your range will be always minus 1. We will not solve it by the sense also. You can easily make out. Put any of the numbers and put 2 and see. 4 minus 2, 2 in the numerator. Denominator will be 2 minus 4, minus 2. 2 divided by minus 2 is minus 1. So any number if you put in the place of x, it will be minus 1. So range is minus 1. Only one number minus 1. So third option. Okay, we'll go to the 8th one now. You can pause the video and note it down. Look at the 8th one now. Domain. Once again, the question is to find the domain itself. And the question is, f of x is equal to root of 4 minus x plus 1 divided by root of x square minus 1. Once again, we have to find the domain. You know what is domain? Domain is what value we can substitute in the place of x such that f of x is defined. If you understand that sentence, it's enough. You can easily find what is domain and range. The value which we can substitute in the place of x such that f of x is defined. That is called domain. Okay. Now let us see. I have to substitute the value of x in such a way that f of x should be a real number. So f of x is defined only when, see here I have root of 4 minus x. So inside the square root I should not get negative value. Root of 4 minus x is there, no. Inside the square root if I get minus value, again it's not a real number. And inside the square root if I get 0, root of 0 is 0 only. And 0 is a real number. Right. Now, what should I substitute here such that f of x should be real? Can I tell 4 minus x should be always greater than or equal to 0? Then only f of x is defined. Not like previous problem. Previous problem was in the denominator. 1 divided by root was there. In the denominator 0 must not be there. But here inside the square root 0 can be there because root of 0 is 0 only. Hope so it's clear. 4 minus x should be greater than or equal to 0. Equal to is also included here. The reason is it can inside the square root I can get 0. Square root of 0 is 0 which is a real number. Okay. Now look here. F of x is defined if this is greater than or equal to 0. And from this I can write 4 is greater than or equal to x. X I am shifting here. Okay. Or if I am writing correctly, x is less than or equal to 4. Okay, one part I solved. So understand, it's not easy. Try to understand. Okay. The problem is not complete now. One more part is there. Once again, even this should be defined, right? Now, when this is defined, if I get 1 divided by 0, it's undetermined form, not defined once again. So I have to avoid 0 in the denominator. So what should I get inside the square root? X square minus 1 should be just greater than 0. In this case it was greater than or equal to 0 because root of 0 can be defined. Root of 0 is 0, only 0 there. 0 is a real number. But here I can't get 0. 1 divided by 0 if I get, it's not defined. So this is defined only when x square minus 1 is positive, greater than 0, not even 0. If it is 0, root of 0 is 0, 1 divided by 0 not defined. For that reason x square minus 1 should be greater than 0. Okay. Now from this I can write x square is greater than 1. That minus 1 if shift here it becomes 1. Okay. Now look here. X square is greater than 1. Okay. X square is greater than 1. So can I tell x is greater than 1 and x is less than minus 1? If x square is greater than 1, what does it mean? X should be greater than 1. What value will substitute in the place of x? It will be greater than 1. Put x equal to 2 and see. 2 square 4. 4 is greater than 1. 3. 3 square 9. 9 is greater than 1. Okay. If x is greater than 1, then x square is greater than 1. Or if x is less than minus 1. If it is minus 1, then it will be equal. Exactly if I put minus 1. Minus 1 square is 1 only. It should be greater than or equal to. But only greater than sign is there. So less than minus 1. Less than minus 1 is minus 2. If I put minus 2 the whole square, it becomes 4. 4 is greater than 1. Minus 3 the whole square, 9. 9 is greater than 1. So what does x square greater than 1 imply? X is greater than 1 and x is less than minus 1. Hope so it's clear. If it is not clear, please rewind and see how. Also I got 3 equations. What and all? One is x is less than or equal to 4. The other one is x is greater than 1. The other one is x is less than minus 1. Now which option is correct? Okay? Which would be the common shaded region here? What is the domain? What is the value of x now? Let us draw the number line so that easily we can make out what is, see, x is less than or equal to 4 and x is greater than 1 and x is less than minus 1. Can you imagine what are those numbers? No, so better if you draw the number line. So I plot the points. If I can plot minus 1 here, 1 will be somewhere here and here will be 4. Okay, let us plot the first condition. X is less than or equal to 4. See, while explaining that subsets and all, intervals and all, I have told you how to draw in the number line. Close interval, open interval, one side close, one side open and all. How to plot it in the number line, I have explained to you. Same now, x is less than or equal to 4. This is 4. Less than 4 means it comes this side. Okay. Less than or equal to means including 4. Including 4 means hollow dot there. And less than 4 means it comes here, this side. Okay. x is less than or equal to, including 4 and less than 4, it comes this side. Okay, this thing is plotted. Okay, next is x is greater than 1. So I have plotted this side. So if you want, let us see the others. I have plotted this side. Okay, this side less than 4 means it goes up till minus infinity. Next condition, let us see. X is greater than 1. X is greater than 1. So here I am having 1. It's not greater than or equal to, only greater than 1. So not including 1, hollow dot here. Okay, not including 1. X is greater than 1. Greater than 1 means it comes this side, which is a common shaded number. What I got this region, okay, common shaded. That is from 1 to 4, okay, not including 1. So open interval 1 and including 4, close interval 4. I got this interval. Still wait, one more condition is there. What is that? X is less than minus 1. X is less than minus 1. Minus 1 is here. Minus 1 is here. So hollow dot. Less than, not less than or equal to, less than. So not including minus 1 and less than minus 1 means this side. This region. Okay. So which is a common shaded region now? One is, look here. You know this is minus infinity and this is plus infinity. Okay. So less than minus 1 means it came up with minus infinity. So open interval minus infinity. I don't know the value of minus infinity, so that's I give you minus infinity to minus 1 and hollow dot here because it's given less than minus 1. So minus 1 open interval. Why open interval? Hollow dot. Minus 1 is not included. X is less than minus 1. Not including minus 1 but less than minus 1. Okay. One part is done. Union. Write union. Combination with union. 1 to 4. Once again this is shaded twice. 1 to 4. And then 1 is not included. Hollow dot there. X is greater than 1. Not greater than or equal to. So open interval 1 up till 4, including 4, less than or equal to 4, including 4. So 4 closed interval. Okay, this is the answer. This would be the domain. Okay, a little bit difficult, but try to analyze. Only these values can be substituted in the place of x such that f of x is defined. Not any of the other value. I can't put any of the value from here or any of the values is greater than 4. I cannot put. If I put, then f of x will be not defined. Hope so it's clear. Especially if this is not clear, please you can clarify with me, okay? And this thing is new for you, writing with union and all. Slowly will come to one by one. So here the option is, first option, minus infinity to minus 1, open interval, union, open interval 1 to close interval 4. And about those intervals, you must be very thorough. You have studied in the first chapter itself. You go to the next one, minus 1. Now the question is to find the range of f of x. F of x is equal to 1 divided by 1 plus x square. The question is find the range. You know what is range, right? We substitute in the place of x such that f of x is defined and that f of x is the range, right? So, looking at the given equation, you can make out that whatever value you put in the place of x, if you put 0, what happens? 1 divided by 1 you get 1. Put some 0.11 and all. If you put 1, if you put 1, what happens? If you put 1 divided by 2, 0.5. If you put 2, so you'll get 0 point only, whatever. And you'll get the values which is greater than 0. You'll not get 0 at like whatever value you put in the place of x, you won't get 0 because it's 1 divided by 1 plus something. So whatever value you are going to get, it will be greater than 0, not equal to 0. Okay, and it's always positive. You won't get negative value also. Why? If you put negative value, while you square it becomes positive. If you add 1, once again positive. 1 divided by positive number is positive number only. Okay. So at any cost, you are not going to get negative number for f of x. It will be positive. And it's always greater than 0. If you want, try some values and see. Put in the place of x some values and check. You can make out. Okay. Now let us find the range. Can I write f of x as y? Okay, I take it as y is equal to 1 divided by 1 plus x square. As I told you, put some values and check. There only you can make out what is the range. Although solving procedure is not necessary. Okay, you can by putting some values and checking each time, you can make out. The value will not exceed what. Okay, you can make out. But still, we can solve this. How? Let us check what is the value of y. For that I can make out the range because y is the range, x is the domain. So if I cross multiply, 1 plus x square will be 1 divided by y. Y you shift here, this you shift here. Okay. And x square will be 1 by y minus 1. That one you shift here. Okay. Now x square will be, here you take LCM. 1 minus y divided by y. 1 minus y whole divided by y. Now what is x? X is plus or minus root of 1 minus y whole divided by y. Okay. And always remember y is greater than 0. Y is always greater than 0. Not equal to 0 also. While looking at the equation, you can make out. Now you see, this is defined only if 1 minus y divided by y is greater than or equal to 0. You know that I am telling from the beginning. Root of 0 is defined and root of positive value is defined. Root of minus is not defined, right? It should not be minus. It can be 0 or greater than 0. Okay. Now if I shift y that side, now 1 minus y is greater than or equal to 0 I'm getting. Now we'll see next. Here y I'm shifting that side. So 1 is greater than or equal to y. Okay, y minus y shift that side, it becomes plus y. So I can write y is less than or equal to 1. Okay, what did I get by solving? Y is less than or equal to 1. Also, in the beginning only I told you, y is always greater than 0. Okay, whatever values if you substitute here, it is greater than 0. Not even 0, it's positive value, but at any cost I am not getting 0. It can be 0.1, 0.2, from those I will get the values. If you put a very small value in the place of x, but I am not going to get 0. You know the reason, it's 1 divided by 1 plus x square. Okay, so using these two conditions, y is the range and the question is find range. I got my range there. Y is greater than 0, less than or equal to 1. So here, if this is 0 and this is 1, y is greater than 0. Follow here, greater than 0 this side. Greater than 0 means actually it comes full. And we have to stop here because y is less than or equal to 1. Less than or equal to 1 means 1 and less than 1. So which region is shaded? Twice. Actually the range y is, y belongs to open interval 0, close interval 1 is the answer. Not including 0 because greater than 0. Okay, greater than 0 but less than or equal to 1 is the answer. Here option 4 is correct. Okay, option 4. Okay, 10th one. the range of, once again the question is range, f of x is equal to x minus box x. Okay, we tell it as a box x, but what is that? This is defined as the greatest integer x. We came across this word set of greatest integer, sign and function, all those things. This is the notation for greatest integer. Now what is this greatest integer? A greatest integer is the value of x which assumes a value which is just less than or equal to x. Okay. So for example, greatest integer x is 1. When it is 1, if x is greater than or equal to 0, less than, if I start from minus 1, when will I tell the greatest integer x is minus 1? X is greater than or equal to minus 1, less than 0. Okay. In case the question is, find the greatest integer for 2.5. What would be the greatest integer for 2.5? Draw the number line and check. If this is 2, this is 3. 2.5 is somewhere here. 2.5. Now the greatest integer for 2.5 will be 2. The number which is less than or equal to x. The number which is just less than or equal to x. So 2. The greatest integer for 2.1 is also 2. 2.2 is also 2. Up till 2.999 it is 2. But for 3 it is 3. 3.1, 3. The value which is less than, okay, less than the given integer. Okay, that is the greatest integer. You have studied the definition. Okay. Now, here the question is to find the range. Okay. Now that is not easy to do by the method. So here let us check with some examples. Okay, examples will give you easy answer. Easily you get the answer. Yeah. If I put x equal to 0, let us see. Okay. If I put x equal to 0, 0 minus box 0, greatest integer 0. So 0 minus, what is greatest integer 0? 0 only. So 0 minus 0 is 0. So if I am putting 0, I am getting 0. In case I put 0.1, let us check in the number line. Okay? Number line, I have put 0. I will put some values which is to the right side and towards the left side of that 0. In case I put 0.1, what will I get if I put 0.1? 0.1 x minus greatest integer 0.1. Okay. So 0.1 you write for that only minus greatest integer 0.1, box 0.1. So look now, 0.1 is somewhere here and here I am having 1. Okay. Which is the greatest integer for 0.1? The value which is less than, the integer which is just less than or equal to the given number. So 0. 0 will be the answer. Greatest integer for 0.1 is 0. So 0.1 minus 0 is 0.1 only. In case if you put 0.2, just think, if you put 0.2, 0.2 minus box 0.2. What is box 0.2? 0. Up till 0.9999 you are getting 0 only. Right, greatest integer will be 0. For the box 0.1, 0.2, 0.2, whatever, the greatest integer will be 0. The number, the integer which is less than that, right? So here, if you put 0.2, 0.3, 0.4, you are getting same, 0.1, 0.2. If you put 0.9, if I put 0.9, what am I going to get? 0.9 minus box 0.9, which is 0.9 minus, what is box 0.9? The greatest integer which is just less than or equal to your integer, and that is 0 only. 0. So look, whatever number I put, in case if it is 0.972850 also, the answer will be the same, 0.97250 only you are going to get. Okay. So I have got the numbers from 0 to 0.9. Okay. In case I put 1, let us see. If I put x equal to 1, what I am getting? 1 minus box 1. What did I get? Box 1 is, greatest integer of 1 is 1 only. 1 minus 1, and that is 0. again the procedure. I am getting 0 only. Next, if I put 1.1, what happens? 1 minus 1, box 1.1. What is box 1.1? The value which is less than integer. So 1 which is 1.1. 1.1 minus box 1.1 will be 1.1 minus 1. Your answer will be 0.1. Put some values and see, you will come to know. From 0 to 0.9 you are going to get. If you put 0.9999 also, you get 0 to 0.999. If you want, put some more options and see. Here the answer will be closed interval 0. Because I was getting 0, while I put 0, 1, 2, 3 and I am getting 0. Closed interval 0, but I never got 1. Okay, I got up till 0.9999. So it's open interval 1 will be the answer. Open interval 1. Okay, if you want, put some negative values and see. What happens if I put here only? Let's see. What happens if I put x equal to minus 0.1. Okay, so minus 0.1 minus box 0.1. What will I get? Minus 0.1 minus, so look here, if this is 0, this is minus 1, our 0.1 will be somewhere here, 0.1, which is the greatest integer here, minus 1. So minus 1, right? So this would be minus minus plus 1 you are going to get. So what is 1 minus 0.1? This will be 0.9. So whatever value you check, you are going to get the values between 0 to 0.9 only. You will never get 1. So this closed interval 0 to open interval 1. Why it's open interval? Because I am not getting 1, but I can get up to 0.9999. Okay. This will do 11th problem. Domain of, once again the problem is domain of f of x is equal to 1 divided by root of mod x minus x. Okay, the question is to find the domain. So look here. Once again here, function is defined, f of x is defined only if mod of x minus x is greater than 0. Okay, if this is greater than 0 only it is defined. If it is 0, 1 divided by 0 not defined. Otherwise we cannot define the function, you know that. Okay, now what is this mod of x? We have studied modulus function, right? What does the definition tell you? It is x if x is greater than or equal to 0. It is minus x if x is less than 0. Right? You have studied this definition. But here we have mod of x minus x. So how can I define the function? Okay. How will I define the function mod of x minus x? Okay. Mod x is x when x is greater than or equal to 0, and that minus x copy as it is. And when it is minus x, mod x is minus x, when x is less than 0, and that minus x you copy as it is. Okay, change that mod x to x and minus x. X if x is greater than or equal to 0. Minus x if x is less than 0. Okay, now what will be this mod of x minus x now? X minus x is 0 if x is greater than or equal to 0. Okay, and minus x will be minus 2x if x is less than 0. This is what I am getting in the denominator. The denominator should be always greater than 0. What happens? See, here in the denominator, mod x minus x will become 0. When it will become 0? When x is greater than or equal to 0. Look here, I should not get 0. I should not get 0 in the denominator, then it will be not defined. So this should not be the given condition. The reason is I am going to get 0 in the denominator. So x is not greater than 0. But I can get minus 2. I can get minus 2, right? For what condition I am getting minus 2x? For x less than 0. So your answer will be domain is x is less than 0. It can be any number less than 0. So your answer would be the first option. It's minus infinity to 0 but open interval 0, not closed interval, because x is less than 0. Once again I will repeat, you see, x minus x here, what did you get? X minus x will be 0 for x greater than or equal to 0. Minus x will be minus 2x for x is less than 0. But according to my condition, f of x is defined only if this is positive. If this is 0, what happens? If this is 0, not defined. And inside the square root, I should not get negative also. So, when I am getting 0, when x is greater than or equal to 0. So, this is not my answer. X greater than or equal to 0 is not my answer. Why? If I substitute any value greater than or equal to 0, I am getting 0 in the denominator. Which should not be the case. But if I put x as minus value, less than 0, then I am going to get minus 2x, which I can get. Okay. So here, 11th one, first option. So I'll just tell the answers. Remaining you can try. If you have any doubt, you can clarify with me. Okay, I'll do which one, you know. One thing I want to tell, that is in the 19th question. See, remaining answers I won't tell you. You try. I will work out and send to you all the answers. But first you try. After 2 days, I will send you the answers with solution. Okay, but you have to try. And for 19th one, I wanted to give one formula. The question is, the number of functions that can be defined from set A to set B. Set A has 4 elements, A, B, C, D. And set B has 3 elements, 1, 2, 3. Now the question is, the number of functions that can be defined from set A to set B. I'm doing 19th one, look here. We're discussing 19th one, okay? Remaining I will work out and send to you. Now you know number of relations from set A to set B is 2 power p cube. This is number of relations from set A to set B. From A to B. Okay, this formula. But if you want number of functions from set A to set B, the formula will be number of elements in set B to the power of number of elements in set A. Remember this formula. So many number of functions will be from set A to set B. So many number of relations will be from set A to set B. So many number of functions will be from set A to set B. The number of element in set A is 4. Number of element in set B is 3. Here the answer will be 3 to the power 4. And answer will be 81. We just remember that. And remaining problems, I'll work out. Okay, you work out first, then I'll send the solutions for you. I'll give it 2 to 3 days time. You solve it slowly, and if you have any doubt, you can ask me. Thank you.